Right. Now we are going to do the rest of the questions. It is question number I told you about the description regarding to the 7b part, right? Now based on that you can find out A, C, E, B, D and F, right? I told it. Now you can do the questions. Write down the balanced chemical equation for all of the reactions described above, right? Yes. So what is A? Now let's see what are the reactions. A is zinc sulfide. So based on zinc sulfide you can write the reaction, right? A is a white solid. It reacts with dilute sulfuric, liberating the colorless gas B, right? And giving clear solution. So you can write the reaction between zinc sulfide and sulfuric acid that produce zinc sulfate aqueous and H2S gas. So it is the balanced chemical reaction, right? Then when the gas B is passed through a solution of acidified dichromate, the solution turns green with formation of yellow-white colloidal precipitate D. So we can write the reaction between dichromate Cr2O7 2 minus goes to Cr3 plus. So if you have 2 here, put 2 in front of chromium. So you have H2S that goes to sulfur, right? So the difference is 6 electrons, 2 electrons. So multiply this with 3, right? So 7 oxygen, 7 H2O, then 14 H plus. You have 6 H plus here, so you can put 8 H plus. So you can write the balance reaction: 4 sulfuric acid plus 3 H2S plus potassium dichromate to Cr2SO4 thrice 3 sulfur and 7 water. Yeah, it is the balanced chemical reaction for the second one. Here we are writing balanced chemical reactions for the description in 7b, right? So yes, this is D, this is D, this is A, this is D, A, gas B is H2S, solution C is zinc sulfate. That is the thing. Yes. Then the gas E obtained by burning D in air. So D is zinc sulfide. Zinc sulfide burned in air that produce zinc oxide and sulfur dioxide gas. Right? Here you need to know the special feature is regarding to the zinc oxide. What is the special feature of the zinc oxide? We know that all aqueous solutions of zinc ions are colorless. All aqueous solutions of zinc ions are colorless. Likewise, all solid compounds of zinc is white. However, for the zinc oxide, you need to know very specific thing. That is, under high temperature, that means when zinc oxide is heated up to some greater temperature, it turns pale yellow. and then again it get white as usual when cooling. So that is very important thing regarding the zinc oxide. Except this, there are no any other colored compounds for the zinc. Only you have zinc oxide, but that is not under room temperature, under particular high temperature, zinc oxide, right? Gas E. So gas E is sulfur dioxide. The next reaction is gas E react with D. So SO2 gas react with H2S gas to produce sulfur precipitate and water again. So it is F. It is F, right? It is F. Anhydrous copper sulfate turns into blue. Anhydrous copper sulfate turn into blue when Fe is added. You can write the reaction for this. CuSO4 solid plus 5H2O liquid. You can write copper sulfate pentahydrate, that is solid. It is blue. Right. The white precipitate which is formed by reacting C with sodium hydroxide. We know that zinc is C is zinc sulfate. So you can write zinc sulfate aqueous plus sodium hydroxide that produce zinc hydroxide white plus sodium sulfate. This is blue. Sodium sulfate. Then zinc hydroxide dissolves in sodium hydroxide to produce sodium zincate. Put 2 here. Na2 ZnO2 plus water. Right? So this is how zinc hydroxide dissolves in sodium hydroxide due to the production of sodium zincate aqueous. And there we have another reaction to write. Zinc hydroxide dissolves in ammonia. Zinc hydroxide dissolved in ammonia. So here I am going to clean the board. So write this first. Write these reactions. I will give you 2 minutes to write these reactions in the given space of this question. I am talking about second part of the question B. Write this. Right. I think you are finished with these reactions. Now I am going to clean the above one and I am going to write these 2 and I am going to write the final reaction, that is reaction of zinc hydroxide solid plus 4 ammonia zinc amine complex Zn NH3 2 plus 2 OH minus aqueous. Right. Those are the reactions for the second part of the question. Right. And then give a method to identify each of the gases B and E. B and E. Gas B is H2S. Gas E is sulfur dioxide. Gas B is H2S. Gas E is sulfur dioxide. Right. Now I am going to clean the board totally. Right. You need to write reaction for identification of H2S and sulfur dioxide. Okay. So we did those in our theory lessons, right? So what kind of reactions we can use to identify H2S? We all know that both H2S and sulfur dioxide are capable of changing colors of acidified potassium permanganate and potassium dichromate. That is a very common reaction, right? Dichromate to chromic, permanganate to manganese. The H2S goes to sulfur, sulfur dioxide to sulfate. Right. So you can't write those reactions for the identification of H2S and sulfur dioxide. Both are capable of changing the color of common oxidizing agents like acidified potassium permanganate and dichromate. However, there we have some observation, important observation regarding to the H2S. What is that? The H2S forms colloidal suspension when it gets oxidized by common oxidizing agents. Right? Yes. So, however, if they ask to write the identification test, you can't write it. You can't write, but you need to understand that. But if you saw that thing in the question, you can recognize that is H2S. It's okay. Right? So that's mean if they said that in the question, you need to take it as H2S. But you can't write it. You have specific test for the H2S. What is that? The H2S, the test for the H2S is the reaction with lead acetate. When H2S gets contacted with the filter paper moistured with lead acetate, you can observe black patches on the filter paper. So that is a characteristic reaction for the H2S. So in the class we learned that it's as Segre reaction. Segre reactions. Lead sulfide. When you put hydrogen peroxide into that means if this is H2S and this is the filter paper, you can observe black patches. Filter paper, moistured with lead acetate. Lead acetate. Then you can observe black patches. These black patches are corresponding to the lead sulfide. When you put hydrogen peroxide onto the black patches, again it gets colorless. Because why? Because this oxidation, lead sulfide solid, this is black in color. When it gets reacted with H2O2, it goes to lead sulfate and H2O2 reduced down to water. So this is very important reaction. I didn't balance this. Lead sulfate is white precipitate. Lead sulfate. You know that? Always there we have two white precipitate, barium sulfate and lead sulfate. Right? Okay. So this is the test you need to write. So how to identify H2S? Right? The test is when it get contacted, when H2S, in other terms B, the gas B get contacted with filter paper moistured by lead acetate, it is possible to observe black patches on the filter paper. test for the H2S. And what kind of test can be used for the sulfur dioxide? That is, there we have two tests for the sulfur dioxide. As I told you in the first video, there we have two tests for the sulfur dioxide. Right? The first one is very famous one. That means when sulfur dioxide get contacted with colored flower petal, moistured with water, it get colorless due to the bleaching property of sulfur dioxide. I think you are familiar with bleaching property of sulfur dioxide, right? Bleaching property of sulfur dioxide. How it happens? Bleaching property of sulfur dioxide. Initially, sulfur dioxide reacts with water in the moisture to produce H2SO3. This is sulfurous acid, the trivial name. The sulfurous acid dissociated to atomic hydrogen. These brackets are correspond to atomic hydrogen. Atomic hydrogen and sulfur trioxide gas. Right? In inorganic chemistry, addition of hydrogen means reduction. So, the colored pigments get reacted with hydrogen to reduce itself. Reduce form of pigments. Reduced forms of pigment, right? Reduced form of pigment. So this is bleaching. But however, when it get contacted with atmospheric oxygen, again the initial color is appeared. So this is not the temporary bleaching effect. So sorry, this is not the permanent type of bleaching effect. This is just temporary bleaching effect, and the impact is reductive. So the temporary reductive bleaching effect, right? Sulfur dioxide. Bleaching effect of sulfur dioxide is temporary and reductive bleaching effect. This is the only temporary one we have. You know, what are the other bleaching substances? Very important. Listen carefully, right? You can write these things if you want in your concept in your concept book that we maintain so far. Right? All the bleaching impact of all the other compounds are just oxidizing. So what are the other bleaching substances? Other bleaching substances are H2O2. H2O2 directly dissociate to water and atomic oxygen. Another one is when Cl2 react with water, halogen react with water, it produces hypochlorous acid and HCl. Hypochlorous acid break down to HCl and atomic oxygen. It is bleaching, oxidizing bleaching effect. Then the other one is calcium hypochlorite. This is said to be as bleaching powder. Bleaching powder. Right? In presence of acid, it produces HClO, and HClO break down to HCl and atomic oxygen. Right? Other one is NaClO, sodium hypochlorite. Sodium hypochlorite. So, in the acidic medium, it turns to HClO and turns to HCl and atomic oxygen. And the next one would be ozone. Ozone directly break down to O2 and atomic oxygen. So, write these things in your concept book. These are permanent oxidizing bleaching effect. Permanent and oxidizing bleaching effect. Right? Write these things in your concept book. I'll give you time for that, 2 minutes. You can pause the video and write this, right? Right. Now tell me, what are the 5 main permanent oxidizing bleaching compounds? Ozone, H2O2, aqueous chlorine, calcium hypochlorite, sodium hypochlorite. Calcium hypochlorite is bleaching powder. That is a common thing in hardwares. You can take it, you can buy it. And sodium hypochlorite, here it is a natural. It is the sodium hypochlorite included in Clorox. There is a blue bottle in food cities. You can find out that, and that is household bleaching liquid, sodium hypochlorite. The trade name is Clorox. Right. All these things are important because they are permanent oxidizing agent. Write those. H2O2, chlorine aqueous, bleaching powder, Clorox, and ozone. Right? All those are oxidizing and permanent bleaching effect. But the bleaching impact of sulfur dioxide is reducing. So here, this is a brief description about bleaching effect. What are the bleaching compounds? Tell me. Sulfur dioxide, temporary, and what? Temporary? Yes, temporary and reducing bleaching effect. All these things, oxidizing and permanent bleaching effect. So keep this very strong in your mind. Right? You know, always your knowledge of inorganic based on listening. Right? And writing. Not the parrot reading. Right? ඔගොල්ලෝ පාඩම් කරනවට වඩා මේවා අහන්න. මේ කියලා දෙනේම අහන්න. හොඳට අහන්න. හොඳට අහලා ඔලුවට ගන්න. ආයෙත් මෙමරයිස් කරන්න. ඒක තමයි ඔයගොල්ලෝ කරන්න ඕනේ දේ. Right? Okay. Now we are going to next question. For the sulfur dioxide here, so we are in the identification test. No, yes, no, test. Right. For the H2S, you can write the lead acetate reaction. When H2S get contacted with lead acetate, it become filter paper. The filter paper become black. Right. Therefore you can write it. And for the sulfur dioxide, there we have flower petal reaction. When sulfur dioxide get contacted with colored flower petal, it become colorless, temporary. Then the initial color is appeared again. Right. And here in this question, in the previous video, I told you about very important reaction of sulfur dioxide. Right. When sulfur dioxide is sent into the solution of copper 2+, the blue color of the copper 2+ solution disappears due to the formation of Q+ ions. So they are the two reactions for the sulfur dioxide. Then what are the reaction for the H2S? Lead acetate, filter paper. For the sulfur dioxide, two reactions. What are the two reactions? Bleaching effect and copper sulfate reaction. Right? Okay. Now, question C. Propose a method to identify each chemical species in the following sets of chemicals using the given method reagents. Right. So this is very important question. Right. So this is the type of questions we frequently got in the papers, uh, in the past papers, mainly 2010 to 2014. But in new syllabus, there are these questions are not frequently given. Okay. Now I am explaining how to do these kind of questions. So the specialty of this question is we didn't talk about this type of question. This is the first time that we are going to talk about this kind of questions, right? Okay, let's see how to do that.